Alright, in this video I'm going to be doing some more 3x3 systems with elimination. And this is from the extra practice from 2.2 from my class. So, but it really is just the CUDA Algebra 2 free worksheet for 3x3 elimination. I'm realizing I'm going to need some more scratch paper here, because I won't be able to solve these systems in the amount of room given. Okay, so I'm going to develop a plan. First, I'm going to eliminate on these y's, because I'm seeing 5y all over the place. So I'm thinking I'm going to do equation 3 plus equation 2 and equation 3 plus equation 1. Okay, when I add these all together, I get no x's, no y's, negative 5z minus z is negative 6z's, equaling 2 plus negative 20 is negative 18. Okay. Now I know that that's going to eventually mean that z equals 3. But I'm not going to lose sight of what I'm doing. I'm trying to eliminate y, so I'm going to do equation 2 plus equation 3. I'll get 4x plus x is 5x, no y's, 3z's, equaling 19 minus 20 is negative 1. Okay. But I just found out that z is 3, so I can go over here and say 5z plus 9 equals negative 1. I'm going to subtract 9, divide by 5, and get, wait, hold on, what have I done? Oh, I copied wrong. Okay, it's 5x plus 9. Okay, there we go. 5x, and then x is going to equal negative 2. And then from there, I'm going to go back to one of my original equations, maybe this one. X plus 5y minus z equals negative 20. So x plus 5y, well, we already know what x is. That's negative 2 plus 5y minus z is minus 3 equals negative 20. So I'll combine these terms, negative 2 and negative 3, and I'll have 5y minus 5 equals negative 20. I'll add 5 to both sides and divide by 5. And then I'll have myself a solution. X equals negative 2, y equals negative 3, z equals 3. All right. All right, number 2, I'm seeing a lot of the same thing. I'm going to really want to eliminate on y because of these negative 5y's and that positive 1y. So, since it's set up really perfectly, I'm going to do equation 1 plus equation 3. And I think I can do these mentally. Negative 4x minus 2x is negative 6x. Negative 5y plus 5y is no y's. Negative z plus 2z is positive 1z. That's going to equal 18 plus 4 is 22. Okay, and then the other 2 is going to be 2 and 3. Right, so I'll have negative 4x, okay, no y's, no z's, equaling 16. Okay, and then I'll be able to solve for x here. I'll say, all right, that means that x is going to equal negative 4. And then I can substitute up here on my other equation that has just the 2 variables, and I can figure out the value of z. Negative 6x is going to be negative 6 times negative 4 is 24 plus z equals 22. And then I'll see, okay, well, z is going to be 22 minus 24, which is going to be negative 2. Okay, then lastly, I'll go back to one of my original equations, and maybe I'll do negative 2x, the bottom one. So negative 2 times negative 4 is 8 plus 5y plus 2z is going to be negative 4. That's equal to 4. Okay. And then I'm going to solve for y. That's going to be 5y plus 4 equals 4. Okay. Maybe you can see how this is going to play out, or maybe you just want to keep solving. I'm going to subtract 4 from both sides. And then I'll divide by 5, but 0 divided by 5, that's still going to be 0. And then my solution here for this one is going to be negative 4, 0, negative 2. All right. 3. Here, my plan is going to be, once again, to eliminate on y. Okay, I hope that this... Okay, yeah, I think this is... yeah, it's going to get a little more exciting eventually. But you see both of these next two, I'm going to continue to eliminate on y. Okay, but maybe... Nope. These are both going to come back with a unique solution. Alright, so I'm going to do equation 1 plus equation 3. Negative x plus 2x is 1x. Negative 5y plus 5y is 0. Positive z minus 3z is negative 2z. 17 minus 10 is just 7. And then I'll do equation 2 plus equation 3. I'll have negative 5x plus 2x is negative 3x. No y's. 5x minus 3x is positive 2, or 5z minus 3z is positive 2z, equals 5 minus 10 is negative 5. Okay, now this is perfectly set up for elimination, kind of like bumping up the difficulty a little bit each time. And that's fine. It's probably a well-designed worksheet. So x minus 3x is negative 2x, no z's equaling 2. And so then I'm going to divide both sides by negative 2, and I get x equals negative 1. Okay. From that, I'm going to go over here, and I'm going to say negative 3x plus 2z equals negative 5. So negative 3 times negative 1 is positive 3, plus 2z equals negative 5. And then I'm going to solve for z by subtracting 3 and dividing by 2. And then I'll go back to one of my original equations, maybe this one on the bottom, equation 3. 2x plus 5y minus 3z minus 3 times negative 4 is going to be positive 12. That's equal to negative 10. Yeah, okay. And then I'm going to have, all right, negative 2 plus 12 is 10. I'm going to subtract 10, so negative 10 minus another 10 is going to be negative 20. And then I will solve for y by dividing by 5, and I'll get y equals negative 4. And so my solution point is negative 1, negative 4. Okay, now this one here. Should have written that. I have to hide it. Okay. Before, I'm going to once again eliminate y. Okay, so I'm going to add equation 1 to equation 2 and equation 1 to equation 3 to make use of that positive 4. If I add the first two equations, I'll get 6x, 0 y's, and 2 z's equaling 24. And then if I add equation 1 plus equation 3, then I'm going to have 9x, no y's, negative 4z's, equaling 24 plus 12 is 36. Okay. Now I'm thinking I probably just want to double this fourth equation. Okay, so 2 of equation 4, and I'll add that to equation 5. 2 of equation 4 would be 12x, 4z equaling 48. And then equation 5 is 9x minus 4z equaling 36. Okay, so when I add all this together, I'm going to get 21x's, no z's equaling 70, 84. Okay, and that's fortunate for us because 21 divides 84, and I see that x is going to equal 4. Then from there, I can go back to one of my 2 by 2 equations and say, all right, 6x plus 2z equals 24. So 6 times 4 is 24, plus 2z, that's going to equal 24. So I can subtract 24 from both sides, and I can say 2z equals 24. And divide by 2, and get z equals 12. And then at the end, I could solve for y by plugging in on one of the original equations. Maybe I'll do 4x plus 4y plus z equals 24. So 4x would be 16. Plus 4y is what we're hoping to find now. And then plus z is going to be plus 12. That's equal to 24. All right, so that's going to be 12 and 16 is 28. Hold on. Hold on, I made an error here. 4x plus 4y plus z. Oh, z is not equal to 12. No. Z is equal to 0. Yeah, because when I did 24 minus 24, that needs to be 0, not 24. All right, and then from here, then z being 0, yeah, that's more like it. 4y is going to be 24 minus 16 is 8, and then I divide both sides by 4, and I get y equals 2. Okay. So my solution is going to be x equals 4, y equals 2, and z equals 0. Right, number 5. All right, now this one I'm going to actually have to make a decision on which one I want to eliminate with, and it's probably going to be on eliminating on t, because I've got 2t, 4t, 4t. I should be able to make that work. All right, so in this one I'm going to have to take the second equation and double it when I add it to the first equation, so maybe I'll kind of lay these out a little more explicitly. I'll say, all right, I'm going to add equation 1 to 2 of equation 2. Okay, so equation 1 is 4r minus 4s plus 4t equals negative 4. 2 of equation 2 would be 8r plus 2s minus 4t equals 10. If I add these all together, I'm going to get 12r minus 2s equaling 6. And then if I was to add, what was it, equation 1 plus equation 3, that would give me this all together, I'm going to get 1r minus 7s, no t's, equaling negative 20. All right, so kind of my options here are, none of them are great. I guess I could divide this all down. Even still, that's not going to be the way to go. I guess I'll eliminate on r by taking this equation and multiplying it by negative 12. Yeah, and I should be able to make it work with the arithmetic. All right, so if this is equation 4 and this is equation 5, then I'm going to take equation 4 and negative 12 of equation 5. And I'll say, all right, 12r minus 2s equals 6. And negative 12 of equation 5 would be negative 12r positive 84s is going to equal 20 times 12 is 240. And it'll be positive because it's negative 20 times negative 12. Okay, now I add all this together. I'm going to get 82s equals 246. Oh yeah, and I can do that. S is going to equal 3. Okay, from there, I'm going to go over here and do r minus 7s equals negative 20. So r minus 7 times 3 is r minus 21 equals negative 20. I'll add 21 to both sides, and I'll get that r equals 1. Okay, and then lastly, I can go back to one of my original equations. Maybe I'll do the middle one. So 4r is 4 plus s, which is now 3, I just realized, minus 2t, that's equal to 5. Okay, so that's 7 minus 2t equals 5. Negative 2t, when I subtract 7 from both sides, that'll be negative 2, and divide by negative 2, and I'll get t equals 1. Okay, so r equals 1, s equals 3, and t equals 1. 6. Oh, whoops. Cover everything quite up, but that'll be all right. So let's see, what's our plan going to be here? Not eliminate on Z, I don't want to do that. I could work with this, but no, I think X's is going to be better. Yeah, because all I have to do is, subtract one from another, or, multiply by -2, and that's going to be easier than, scaling this one up by 6. Keep the numbers small. So I'm going to do negative of equation 1 plus equation 2. Okay, so the negative of equation 1 would be negative x plus 6y minus 4z equals positive 12. And then regular equation 2 is x plus y minus 4z equals positive 12. Okay, I add these two equations together, and I'm going to get no x's, which was the idea, 7y's, negative 8z's, equaling 24. And then if I want to use equation 1 maybe to get rid of the x's down here, now I could use equation 2, it doesn't really matter. I'm going to multiply equation 1 by -2, and then that will give me, and then I'll add that to equation 3. Okay, -2 of equation 1 is -2x plus 12y minus 8z, -2 times 12, positive 24. Then get rid of that. Positive 2x, positive 2y, positive 5z equaling -15. Add these together, and I'll get 0x's, 14y's, minus 3z's equals 24 minus 15 is 9. Okay. Now from this, I can see I'm going to want to eliminate y off of these two, so I'll take equation 4, multiply it by -2, and add that to equation 5. Okay, it is going to work, and I'm going to add these together. 0y's, 13z's equaling -48 plus 9 is -39, and z is going to be -3 when I divide both sides by 13. And alright, then from here I'm going to go back to one of my original equations, maybe this one. This one looks good. 14y minus 3 times -3, okay, so that's plus 9, is equal to 9. I'll subtract 9 from both sides. Divide by 14. 0 divided by 14 is still 0. Okay, so I've got y equals 0 and z equals -3. So I'll go back to one of my original equations. Maybe x plus y minus 4z equals 12. I like that one. X plus y is 0. Minus 4z is going to be minus 4 times -3 is plus 12. That's equal to 12. Okay. Well, that just must mean that x is 0, right? Because 12 plus 0 plus 0 equals 12. Okay, and then my solution point is going to be 0, 0, -3. Number 7, I'm thinking, well, you know what I've said in the past is if you see one of those and you've got one with just 2 variables, that oftentimes it's set up well for substitution. I think that this one is not well set up for substitution on the one that's just got 2 variables on it. So I'm thinking we're going to want to eliminate, let's just eliminate z, Because we've already got 3x plus 2y equals negative 25. I'll just eliminate z out of the first and third equations, and that'll take me down to a 2 by 2. Okay, so I got a little distracted. I'm going to eliminate on z though, but based on what I'm seeing here, I'm going to take the third equation and multiply it by negative 2. So I'm going to have x minus y minus 2z equals negative 6, and I'm going to multiply everything by negative 2 here, so that would be 8x minus 2y plus 2z equaling negative 24. Add these all together, and I'll get negative 3y 9x's minus 3y equaling negative 30. Then I've also got 3x plus 2y equals negative 25. And then I'm going to kind of combine these two equations, and I'll say, all right, what's going on here? Maybe I'm going to eliminate on x for sure. So I'm going to take this one and multiply it by negative 3. And so I'd have negative 9x, negative 6y equaling, okay, multiplying everything by negative 3, so it'd be positive 75. Okay, so now I'll add all of this together, and I'll get negative 9 times y equals 45. It's telling me y needs to equal negative 5. I divide by negative 9. Okay, 3x plus 2y equals negative 25. So 3x plus 2 negative 5s equals negative 25. Add that over here. 3x equals negative 15. Divide by 3. X is also equal to negative 5. And then I can go back to one of my original equations that has a z in it. Maybe this one. So negative 4x is going to be positive 20. Plus y is negative 5. Minus z equals 12. Okay, so I've got 15 minus z equals 12. Okay, so that must mean z is 3. And my solution point is negative 5 and negative 5 and 3. All right. Okay. Here, background sheets are slipping. So, okay, this is not ideal, right? None of these are, we're going to have to do some multiplication here, right? There's nothing that's just lined up perfectly for elimination. We got to be ready for that too. I'm thinking because this one's got a negative 4a and a positive 4a, I'm just going to try to eliminate on a. All right, so first one I'll do will be easy. Equation 2 plus equation 3, the one that's already set up for elimination. All right, so I'm going to add, so I'll get 6b, 6c. Equaling 9 minus 6 is going to equal 3. Okay, and then I'm going to, I don't really have anything else to do besides multiply this one by 5. So 5 of equation 3 will be negative 20a. Yep, that's going to stay on screen. 5 of 3b is going to be 15b. 5 of 3c, also 15c. And that's going to be 5 times 9 is 45. And then 4 of equation 1 is going to be 20a, 20b, 20c equaling negative 80. Okay, I put all this together, I get no a's, 35 b's, 35 C's equaling, oh, I know what we can do here, is going to be negative 45. All right. Now, I've got a 2x2 system. It's in B and C, but the numbers are pretty bad, right? But I see that I've got this 35, 35, and that 6, 6 thing. So what I'm going to do is I'm going to kind of like simplify these equations down to just B plus C. I'm going to take equation 4, and I'm going to divide it by 6, and equation 5, and I'll divide it by 35. And this is not something I do very often, but I can see where this is headed, so I'll show you why I would do this. So 1/6 of equation 4 and 1/35 of equation 5, and maybe I'll even call it negative 1/35. So 1/6 would be B plus C equals 3/6 is a half. Okay. And then over here, if I divide by negative 35, I'll have negative B minus C is going to equal negative 45 divided by negative 35, which I know is not going to be negative half, right? So when I add these all together, I get 0 equals, I don't know, something non-zero. Specifically because I'm adding two positive numbers together, and it's not going to be 0. And so if I have 0 equals non-zero, that's not true. And so I know that this one has no solution.